Hello everyone, welcome back to our Mastering C++ STL series. My name is Puneet Kansal. I have 12 plus years of experience training the students, preparing the students, especially for the MAANG companies. So if you are targeting for MAANG companies, you are at the right place. And we are learning a tool that is required for preparing for the MAANG company. Actually, preparing for the MAANG company is a two-way process. First thing is you need to be master in one language. Language is a tool, so you need to be master in one language. You can choose any language of your choice. So people ask me which language to choose. So you can choose based upon your choice, doesn't matter. You can choose C++, Java, Python, JavaScript, whatever language you like, choose that language. In this series, we are covering our focus is on C++ STL series. Our focus is on C++ STL series. Okay, so this is our last class for from the C++ STL. So if you have not taken this series, you can go to the description and you can register for this course. This course is free of cost. You will also get certificate if you will complete all the previous video and this video. Although this video is independent of previous video, you do not need to know anything from the previous video. You can attend this class and you can understand about this data structure, or you can say container, list container, forward list container, and there are many algorithms in C++ STL. We will see those algorithms. Okay, so I was telling that, okay, this is the two-way process to go to the MAANG companies. First one, you need to be master in particular language. This is what we are doing over here. This is a tool. So after this, you will be master in that. You will be having sufficient information. After this series, you will be having sufficient information to prepare for the second step. And the second step is the mastering DSA. Mastering DSA, that will be definitely, if you are going to product-based company, that will be the first, second, sometime third round also, even fourth and fifth round also from DSA itself. Okay, so Google usually love the most DSA. Okay, and so second step, first step we are completing here. Second step you can complete by taking mastering DSA course. So let me show you, if you are coming here first time, so let me show you people how you can get that second step, how you can complete that. I'm going to the, let me open a browser. Let me down it and let me open a browser, and let's go to the iNeuron website and go to the courses in the bootcamp and the DSA, and here is our mastering DSA course. Second step to go to the product-based company. First step we are already covering. This is the second step. In this course, you need to enroll. You need to come here in the courses DSA. In this course, you need to enroll. You will find out all the information about this course over here. I can assure you one thing that, okay, after completion of this course, if you are serious means if you are doing what I'm saying, if you are doing on daily basis practice, I will give you the problem on daily basis. And if you are doing that, then there will be no problem in concepts, because that will be crystal clear after my session. That I'm sure. That is my surety. After that, second step will be left. You need to practice. That is at your end. And even I have divided the task into smaller tasks. Even I bring it. I'm using a divide and conquer approach, and bringing the big problem into smaller problem. And we need to solve the problem on day basis. And we are going to do it for 4 months in this course. And after that, there will not remain any reason. You will say yourself, there will be no reason that, okay, you will not be getting any product-based company. Okay, so this is the second step. You can register for this. Let me move to this session now. Before moving on, please let me know in the chat box if I'm properly audible or not. Hello Mandeep, nice to see you back. Hello Divya, nice to see you back. So great, this is our last session from C++ STL. You people consumed complete C++ STL. Believe me, you will not face, you can check out any problem and you will not find out any problem where if you're coding with C++, then I don't think you will face any problem. You will not face any problem. That is confirmed. So before moving on, please confirm me I'm properly audible or not. Please confirm in the chat box. Am I audible properly? Please confirm in the chat box. Yeah, ask your doubt. That is important. Ask your doubts. That is important. Ask your doubts, whatever doubt you have. But before that, confirm me. Am I audible? Audible and visible. Thanks, Mandeep, for replying. Keep asking your doubts. Your doubts are more important than any new information we will be getting from here. So keep asking the doubts. That will be the most important part. And that's why we are here. Otherwise, we can take the recorded classes also. We have doubts with us so that we are live here so that we can ask our doubt. Creating an roadmap, what is the... Okay, so you are asking creating unordered map, what is the time complexity? Let me click over here. So this is a question from Divya. Divya is asking, we want to create an unordered map and what is the time complexity? Divya, unordered map is created with the help of hashing, with the help of hash table. So creating the hash table take constant time. Creating the hash table take constant time. So creating the hash unordered map also take constant time. That's it. Very simple. Even I can add more thing. Performing most of the operations on unordered map will take constant time. On average, I will use the word on average. Okay, because in hashing, on average, this take constant time to perform various operations. Constant. So creating a hash table take constant time, performing the operations take constant time. Another map is created with the help of hashing, so that's why that is taking constant time. That's it. Fine? Is that fine? Okay. Please confirm me if still any doubt, you please confirm me. Otherwise, okay, let's move on. So we have already covered introduction to C++ STL, templates, iterators, pair, vector, stack queue, DQ, priority queue, unordered set, multiset, unordered map, multi-map. Today we will complete this part. This part will be completed today. And if you have not consumed this part, don't need to worry. First take this lecture, today's lecture, and after that you can go to previous lectures. So these lectures are not that much dependent on each other. Little bit concept might be I will be using, yes, like iterators I will be using. That will be used most of the places. Fine, otherwise you can understand the concept. That is not a big deal. Fine, okay. So let's start with the forward list and list. Let's start with the forward list in C++ STL. This is a container. This is not a container adapter. This is just a container in C++ STL. Actually, forward list is the implementation of singly linked list. Okay, you know singly linked list. So this is the singly linked list. Okay, and this is your head. This is your tail, you can say. So this is the inbuilt singly linked list with you people. Okay, this is just implementation of the singly linked list. We will talk about the forward list, which is provided by C++ STL. If you want to use the singly linked list, you can use it. Fine, okay. Let me erase this and let's go deep dive in the forward list. That is singly linked list. This is the structure, you can say, just like a singly linked list only. This is the the name is pointing to the starting node, and okay, this is the end. This is showing the end of the singly linked list or forward list. Singly linked forward list is the implementation of singly linked list. That's it. Forward list is the implementation of singly linked list, like this. This is a singly linked list. This is a singly linked list. Actually, okay, I should modify this thing. I think this is not the right diagram. This is not the right diagram. This is having two spaces, one is here, one is here, one is here. This is not the right diagram. Let me remove it. So this should be, the diagram should be like this. 10. Okay, begin, you know, begin is the, this function is generating the iterator, which is pointing to the address of the starting node, and this is pointing to the next node. We don't have two addresses. We don't have two addresses. That is in the case of doubly linked list. Okay, so here this diagram I think is not correct, so I'm removing it. So here we are storing the data in the form of singly linked list, and when you will call the end function, you people already know, end function points to the address which is past the last element, not the last element, past the last element. So address end is pointing here at this place, past the last element. So this is the structure of singly linked list, and forward list also, you can say that forward list also. Okay, fine. So whatever operations you can perform, whatever operations you can perform, whatever operations, all the operations which you can perform on singly linked list, you can perform that on forward list also. Same operations, same way, same time complexity also, same time complexity also. So here in singly linked list, how much time this will take to insert a node at the starting, at the end, at the middle, how much this will take to search the elements, same, everything will be, same time complexity will be taken over here for the operations on the forward list. Okay, on this data structure, if you will insert, delete, search, all these operations will same amount of time as taken by the singly linked list. If you have any doubt in time complexity of singly linked list, somewhere you can ask me. Okay, you can ask me, we can discuss that. Otherwise, just simply one thing you need to know, all the same time complexity will be taken, same operations you can perform same way, because this is just at the back stage, this is actually singly linked list only, forward list. So how to create that in C++ STL? What is the syntax for that forward list? We already know that the syntax is almost same for all the containers. So this is means we have a keyword. We have a keyword. This is the keyword. Keyword. We know that this is data type. What type of data we are going to store in our singly linked list? And this is the name of our singly linked list. F1 we give, whatever name you can give. That's it. This is how we create the singly linked list, or you can say forward list. Okay, we created just, we initialize the singly linked list or forward list. Okay, like I will call it forward list. Forward list we initialize. This is the keyword, this is the data type, the name, and we initialize is with these numbers 52917. So we initialize over here itself. So this is how we create. That's it. This is how we create the singly linked list. And if you will ask me, sir, how much time this will take? How much time this take to create this singly linked list? I will say constant, because we just created a pointer head. We just created a head. We did not create a linked list. Here we created the nodes 1, 2, 3, 4. So if n elements are there, I will say to create this will take order of n time. This statement will take order of n time, because one by one you will add the nodes in the singly linked list, one by one. So if n elements are there, order of n time. Any doubt you can ask me anytime. Your doubts are more important than any new information. So I just tell you that, okay, forward list is nothing, a singly linked list only, and the operations are same for both of them. These two people are just like same. Okay, and their time complexity is also same. This diagram is wrong. Okay, and this is how we create the forward list. This is another way to create and initialize immediately at the same time. And okay, this is just showing the low level. Okay, this is showing the structure, means how lists are attached with each other elements. So here one more point you can note is that this data are not in contiguous memory location. No, this data is not in it's not coming like 100, 101, 102. These data, these nodes can be, these data can be at, can store at different memory locations. Like maybe this first node, I think that is visible, so that is storing at 100 location. This is I don't know, this is storing at 200, this is might be at 500, this is 300, this is 600, this is 400, I don't know. So different data elements, different nodes are storing at different addresses, just like a singly linked list. It's a singly linked list only, forward list. So you can store the character, you can store the strings, you can store any data type. Actually, you can store other like string, character. Also, you can store into the singly linked list. Okay, you can change it with the character and string also. Just like you need to store the data over here, so you can store the data. So these all containers are implemented in the form of template. Okay, so you can send the this template can accept the different type of data. Either you pass integer, either you pass character, either you pass string. Okay, fine. So this is the basics of the singly linked list. This is the basics of the singly linked list. Now let's check out the methods, functions of the singly linked list. This is assign function is to assign the value, to assign the value to the forward list. We will see, okay, how to assign the value. There are different way to assign the value. Front function will retrieve the first element. You know that in singly linked list, to retrieve the first element, this take constant time. But to add the new values, that take order of n in worst case. And push front, if you want to insert at the front, constant time. If you want to pop from the front, again constant time. If you want to delete from the front, insert from the front, constant time. Insert after, you're inserting at particular location, then you will use the method insert after. Erase after, if you want to erase a particular node, again that will take actually you will erase after a particular node you will delete. Okay, here why we are mentioning order of 1, because here we will provide actually at which place you want to delete. The place is provided to you. You do not need to go from the first location to that location. So place is provided to you. That's why that is constant time is written over there, because you do not need to go over there. And after reaching to a particular location, you can delete the node, you can insert the node in constant time. Okay. Remove the element, remove the element, remove all the elements from the list. Remove a particular element like this value will remove, so that will take order of n time. Clear, this will clear the list. Empty, this will empty the clear means clearing the data. This is checking list is empty or not. Reverse, this will reverse the list. That will take order of n time, reversing the list. Sort, we can sort the list also. What is the time complexity? N log n time. Fine, these are the various operations we can perform. Mandeep, you can check out that thing. I have not checked out that. I do not even find any problem where I use the nested forward list. You can check out. You can do experiment over that. Okay. Fine. Okay. Now I'm going to apply these functions. Let me apply these functions. Let me go to the browser and let me open the C++ online compiler, and let me apply all these functions. You please keep helping me. You please keep helping me. Okay. What will be the output? I will ask you people. You need to help me. That will actually increase the learning from 20% to 100%. So let me add the header files. Only two header file, these one header file and one namespace we use. Okay, and Okay, so how to create it? Forward list, simple. Write the forward underscore list. So that is visible to you people. Let me be little bit more side. So forward list, angular braces, and what type of data you want to store, and name of the list. So let's suppose name of the list is F1. So that's it. We created the forward list. And if we want to assign some data to it, so there's a assign function. So let me write F1 dot assign. So we can assign the values. So we need to we can pass the value in curly braces like 1, 2, 3. So we passed these 3 elements, and we inserted the 3 elements. We inserted the 3 elements inside the F1, inside the F1 singly linked list or forward list. Okay, so assign is assigning like this. We can assign, we are assigning 3 values to this forward list. That's it. Now I'm creating one more list over here. I'm creating one more list over here. That is F2. So this is the again forward list F2. But right now I'm initializing it with the some values 52917. I will use them actually. And I'm creating one more list actually, that is F3. So this will be requiring me to perform all the different operations on the forward list. So this is the third forward list we created, F3. We created 3 forward list, F1. Assign, okay, we check out how to assign the values. Directly also you can assign the values, and this is another list we created, that's it. And after that, okay, now there's another way to assign the value. With the help of assign function, now I'm assigning the value to F3. I'm assigning the value to F3 list. So with the help of assign function, what we are doing is we are storing 10 5 times. 5 times we are storing the 10 inside the F3. So 10, 10, 10, 10, 10. 5 times 10 we stored into the F3 forward list. That's it. I'm taking one more forward list. Okay. F4. Now there is one other way to assign we can assign the value from one list to another list also. One list to another list. So I'm taking the data from F2 and giving it to F3. Yes, Divya, we can use the loop also to insert the data. Here what we are doing is we are taking the data from F2 list and storing into F4. Yes, we are taking the means, just I show you that, okay, how to assign function is used here one way, assign function is used here 2, assign function is used here 3. With 3 way, now we know how to assign the value to a forward list. One is just pass the value in the curly braces. Another one is if you want repeated elements, then like if maybe you want to store 0 or maybe 10, 5 times you want to store 10. So we store 5 times 10s in F3 list. We can take the data from one list and copy it to other list. This can also we can do. Yes, this can also we can do. So we just check out how to assign the value in 3 different ways. Okay, 3 different ways. Fine, okay. Any doubt in this you can ask. Otherwise, okay, now another function is the front function. Another function is the front function. Okay, let me write over here. So let's suppose I want to print the front element of F4 list, F4 dot front. So this will print the front element of the F4 list. So can you tell me what should be the output for this? Can you please reply? Keep replying. Let's make our session more interesting. Please keep replying. That will be requiring. What will be the output for this? Can you please tell me? So that we, all of us, we remain on the same page. So you people are saying 5. Let's see if that will be 5 or not. That is showing some error. And what is that? At the 30th line, that is C out, not count, that should be C out. So let me run it again. Forward, WARD, forward. Let me run it again. Yes, that is printing 5. Yes, that is printing 5. Yes, okay. So we now know that okay, front function can be used to get the front element of the list. That will take constant time actually. So let me print all the elements from the list. Let me print all the element inside the F1 list. So I'm just with the help of loop, we are pointing to each element inside the F1 and we are printing that element. Okay. So F1 is this one, 1, 2, 3. So that should print 1, 2, 3 only. So the elements in the first forward list is 1, 2, 3. Yes, we have printed the element, fine, okay. Now we want to insert the element. So let me write over here another function. So let's keep executing these functions. Any doubt anywhere you are coming, you can ask me. Okay. So in the first list, let me push the element at the front. For that we have a function push front. Push front. So we can use the push front. Let's suppose I want to store 5 in this. So with the help of push front, we can insert this element inside the first list. Okay, let me run it. And so this is one way to insert now. Now we can push the element with this function. And there is an insert function also. I'm going through different function. That's it. There is an insert function also. There is an insert function which will. There is an insert function. Insert after means after a particular index, you can this will store these elements. So actually after first element, this will store 1, 2, 3, 4 inside the F1. Okay, this will store inside the F1. We can print again. So let me print. Let me copy this printing loop and let's execute it and let's see. Can you tell me, okay, what should be the output? You people please tell me now what should be the output after performing these two operations. Please keep telling me what should be the output. Initially we have 1, 2, 3 inside our F1 list, 1, 2, 3. After that we push 5 at the front and here after this location we inserted some more elements. So F1 is this 1, 2, 3. We have 3 elements in that 1, 2, 3. Mandeep, we already printed here F1 and that is showing 1, 2, 3 elements. So 1, 2, 3. Okay, Divya is saying 5, 1, 2, 3, then 4, 1, 2, 3, 4, 1, 2, 3. And Mandeep is saying 1, 2, 3, 4, 5. Okay, different answers we are getting. Actually, so we are printing 5, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. How we are getting this? Initially we were having the 1, 2, 3. Then we inserted the 5. Okay. After inserting the 5, now 5 is at the front. So after 5, we inserted these elements. So okay, let me write over here. Initially we were having 1, 2, 3 in our list. Then with this push front, we inserted 5, and after, with this insert after is used for inserting after a particular location, after a particular location. So begin will point out here, begin will provide this location, and after this location we can insert the element, these elements over here, 1 2 3 4. So this will be 5 1 2 3 4 1 2 3. Is that fine, Mandeep? Fine, okay. So just going through the function, don't nothing to means no logic, nothing, just why I'm asking to you people to check out this, because if you are checking out, then this, then you can means take it better way, rather than I will keep speaking. That will not go, that the learning will not happen in much better way. If you will be answering, then learning will happen in better way. We can pop from the front also. We can pop from the front also by using pop front. So let me write F1. Let me write F1 dot pop front, pop underscore front. So we deleted the front element. Pop front is used for deleting the front element, just going through different functions. Okay. So this will now delete the 5 actually. This will delete this 5. Fine, okay. Now I'm writing for the erase function. Okay, I'm writing the erase function. Yes, 5 deleted. You people please tell me what will happen after this code. I'm writing some code over here. You please tell me what will be the output after this code. I'm not telling you, because erase you already know. So erase is used for erasing the element at after a particular location. After a particular location, this is the location, this is the reference after which this will delete the element. Okay. So can you tell me, okay, what will be the output for this? We have iterator 1 only. 5 is already deleted. 5 is no more. Now this is pointing to where? This is pointing to 1. F1 dot begin is pointing to 1. After that, okay, this is the new function. Advance function is used to advance your iterator. Your iterator is at the 0th position. So that will reach to 2th position. You will add 2. So if you want to advance your iterator, move your iterator to next position. So in here, this begin function created the iterator for the starting element, 0th element. You advance it to this location. So your iterator is now here at this location. Now this will delete the element and point to the next element actually. This will start pointing to the next element. So let me execute this code. Okay, I do not printed it actually. So let me print also. Copy. Meanwhile, you can also reply and paste. Run. So okay, 5 was already gone. 5 was already gone, and after that, okay, we started from here, 0th location, and we reaches over here, and erase after will delete the element after this iterator. So this will delete the 4 actually. This will delete the 4. Name is itself signifying that, okay, we are deleting erase after iterator. Erase after iterator. So we deleted this element 4 from here. Fine, okay. Yes, Divya, you are right. In class, this doesn't matter, right or wrong. That will matter, yes, but in exam. So just keep doing it. We are just going through different function, nothing very fancy we are doing here. It's like a tool we are learning. we need to use these functions. This function will be used to us when we will use them actually. Okay, it's not like that. Okay, either you are coding too much, then you will remember them, and even if you will leave the coding for some days even, then you will forget about these functions. So for in that case, okay, we can ask to the Google. Google will provide us all these functions. But once let's go through these all important function. I'm covering the most important functions which are asked 99.9% in the questions. So I'm covering those only, and I'm not covering exactly complete because they are not used any except the exceptional cases. So we are just going through these functions. Just need to go through. That's it. That is later on if you will see them, then you will not freak out. Okay, what is this? And you will find out that okay, that will be I have already gone through this. Your brain will tell you. Okay, fine. So again, I'm writing 2 lines. You need to tell me. I'm not going to tell now. You think yourself. Okay, I'm not even telling you what these functions are doing. Let's see if you can answer without explaining anything. What will happen after executing these 2 lines? Because I cannot make more complicated to this. You please tell me what will happen. Okay, you just tell me. You just try to find out what will happen after this. Then I will tell. Let me take this print statement, and we can print so that we can find out what actually happens over here. These are the 2 statements we have. Can you please try and reply? What should be the output? Last output you already have with you. This is the last output of F1, and after this operation, what should be the output? You need to reply. Hello Puneet, nice to see you here. I love you too. Puneet is my actually the student from previous batches. And Puneet meets Puneet. Okay. Next, Divya. Yes, I'm not telling you. Okay. Next is actually just like advance. Advance is moving your pointer. Okay. Next is also moving the pointer. This will move up. This will create a pointer and move it to the 5 locations. And let's suppose you start from the 0. Yes, you start from the 0 and you add 5. So you reach to which location? 5th location. So the address of 5th location will be in this iterator. The address of this location will be in this ITR2 iterator. Fine. Now can you tell me what should be the output? Please tell me what should be the output. Next is again moving your iterator, like you start from 0 and then moving to 5. So now you are at the 5th location. The 5th location address is here. First location address from the previous. Okay, let me remove this add. They have put the add. How to remove it? Okay, fine. You can tell me. So this will actually erase the list of elements. This will erase the list of element. Okay, we are passing the starting location and ending location in your list from where to where you want to delete. Okay, that's it. So this is deleting. Erase, just I want to show you that okay, erase is working in different way. If you are giving a particular location, then it is deleting the element. And if you want to delete a list of elements, again you can delete it with the erase after. We can delete it with the erase after. So let me run it and check out. So last F1 value was this. Last F1 value was this. After that, we actually deleted these two elements, and we were why we deleted these two? Our pointer was here, our iterator 1 was here, ITR 1 was here, and ITR actually ITR 2 reaches to the end. ITR 2 0 1 2 3 4 5. ITR 2 reaches here. ITR 2 reaches here. ITR 1 is at the 3. So what we are doing? ITR 1 is at where? ITR 1 should be at 1. ITR 1. Let me check out where is ITR 1. ITR 1. So okay. So yeah, after deleting the element, after deleting the element, okay, if ITR 1 is here, will be updated to next element. So we deleted this element. We deleted this element, and then after deleting the element, we will point, the ITR will point to the next element. The ITR will point to the immediate next element. So ITR is at the 1. After deleting the element, here we deleted the 4. So after deleting the element, then ITR will point to the next element. So now from here to second ITR is pointing here. Second ITR 2 is pointing here. So we are deleting the element starting from ITR 1, delete this, but we will not include this. We will not include this. So we do not include the last element. Okay, we do not include the last element. So this is not deleted. These two elements are deleted. 1 and 2 are deleted. Simple, the idea here is that this is deleting a range of element. Inclusive, this what I want to tell you, inclusive, this is inclusive, this is exclusive. This is what I want to tell you, that's it. This is inclusive, this is exclusive. Hello Rohan, nice to see you here. Okay, fine, this is the idea. Idea is this: we are deleting the element starting from here and going, we are not including this. Before this we are deleting, that's it. We are deleting list of element. Fine, okay. So let me erase this board. Okay, and let's check out the other functions now. Let me, okay, you people please keep telling me what is happening over here. So ITR 1 will be the, okay, we are, this should be the ITR 1. That is inclusive, and this is ITR 2. That is exclusive. So we are deleting these two elements. Is that fine, Divya? Please confirm. Please confirm. ITR 1 here we started the ITR 1, and after that we move it to the 2 steps. So in the starting, that was at the 0th location, then that was pointing at the 2nd location. Okay, so let me repeat it again. Initially this was at the 0th location, because this is giving the address of 0th location. Then we advance function is used to advance your iterator. So that will add 2 in this. So this will be pointing to the second location. This is the list, I think, in which now updated one. Yes. Now, so after deletion, actually, this is actually what this is doing is this is deleting the element which is coming. So okay, we delete the front element 5 here. We deleted the front element 5 here. This is the list we need to start. We deleted the front element. We deleted the 5 over here, and after that we created the ITR. And after we go to the second position, this is the second position. Okay, then we deleted the ITR. We deleted the element after this ITR. So after deleting the element, this will be updated actually. This will be updated over here. And after that, what we are doing, so now 4 is not here. Now ITR 1 is pointing here. ITR 1 is pointing here. And ITR 1 we have with us. So we created another ITR 2, which is starting from 0 location and adding 5 in that. So if we start from here 0, 1, 2, 3, 4, 5. So this is pointing here ITR 2, and after that we pass it to this erase after, and this will delete the elements which will lie in this range. Is that fine now? Is that fine? Please confirm. Please confirm. Okay, fine. So I'm adding one more function over here, remove. So if you want to remove a particular element, okay, let me pass this function, and then I will take the question from Divya also. So let me take first of all this another function, that is remove. If you want to remove a particular element, you need to pass that element. Like we are passing this 30, we want to delete 30 is not here. 30 is not here, so let me pass 3. So if you want to remove a particular element, then can you please tell me what will be the output? Meanwhile, okay, let me. Yes, yes, Divya. Next is moving again. Next is just like the advance only, but if you notice that advance was not returning. Advance was what advance was doing, that was not generating any, but that was not generating the, that was not returning anything. Advance was not returning anything, but here I was in need to get iterator, okay, so that I can pass it as a parameter. So next, the difference between advance and next is that this is not returning the returning the iterator, final iterator. This is actually what this is doing. This is updating ITR 1 itself. Okay, but this is starting from this and going to 5 location, 0 plus 5, and the address of 5th location is stored here. I was using it. I need to pass it over here, so that's why I use the next. Otherwise, I can do with this also, but I need to write another line, this line. Okay, then I can do that. I can use these 2 steps in place of this 1 step. I can use these 2 steps in place of 1 step. My motive was just to show you this advanced function and this next function. That's why I use both of them. That's it. My motive is that I just make you familiarize with these all functions. Okay. And can you tell me, can you guess what will be the output? Last output is with you. That is 1, 2, 3, 3. Can you tell me what should be the output? 3 is the value we are passing. And this is the last your F1 iterator, F1 forward list. Divya, your reply please. Divya is saying 1, 2. Let's run it and check out. We are not printing the elements. Let me print them. Let me copy and paste this list over here so that we can see what actually is happening in our list. So yes, we are getting 1 and 2. So what this will do is this will remove all instances of 3. So this will remove all the instances of 3 actually. Okay, this is not deleting one element, this is removing all the instances of 3. Okay, fine. So next function is I want to sort the elements, but we have only 2 elements right now. So let me add more. Let me work on F2 now. Let's start working on the F2 list. Okay, let's start operations on the F2 list. So I'm performing some operation on the F2 list now. So first operation, okay, we are performing on F2 list is let's sort function. We can sort the list by using sort function. F2 dot sort. So this will sort the F2 list. That's it. This sort function will directly sort the list. So let's print the list and we can check out that. Let me copy and paste the okay, and let's see. Okay, this is the F2 list. So let me write F2 over here, and this will sort the elements, and this will take n log n time, 1 2 5 7 9. Yes, this is sorting the elements. Sort function can also be used to sort the list, but this is taking n log n time internally. Okay, now okay, we can reverse the list also. So for reverse, we have a reverse function. So let me write the reverse function. Here is the reverse function. Okay, let's apply it on the F2 only. So this will reverse the list. That will be 97521. So reverse will reverse the list. Okay, so let me cut it from here and let me paste it with the sort itself. So now this will sort and this will sort in increasing order and this will actually reverse it. So that will be in decreasing order now, 97521. So reverse function is also there, and this is our favorite function, that is that will clear all the data. Let's suppose from the 2 clear function to clear the list. Fine. And the last function, okay, I'm sharing here is the empty function. So this function will actually, we know that empty function will return 1 if the list is empty. So yes, we already cleared the list, so this will return 1 because the list is empty. Yes, this is returning, let me make it upside little bit. So yes, this is returning 1. This is returning 1. Okay, we can see that. So yes, so we gone through various function now, that's it. So let me go to the PPT, and these are the functions we check out. You can check out this. Any doubt in this you can ask. Fine, okay. Now that's it about the forward list. So we have covered, these are the most important functions that is required in the forward list. We know how to create that, we know how to create the list, and we know how to perform the various functions in that. We check out that, that's it. Now let's check out the list in C++ STL. We check out the forward list. Forward list is implemented using singly linked list. This is a doubly linked list actually. This is the doubly linked list. So how doubly linked list look like? This is a node. You can go both side, right side, left side in the list you can move. Okay, so every node is having the two address of previous node, address of next node, address of previous, address of next, previous, next. So like this way, okay, this doubly linked list will be created with the help of list. List is creating the doubly linked list. So let's check out. Yes, this is the one diagram. Okay, you can see over here. So we can go back and forth. And in the starting, we have the address of the starting node. So list in STL is implemented, is the implementation of doubly linked list. Okay, so whatever operations you can perform, all the operations which you can perform on doubly linked list, that you can perform also on the list. Okay, same operation and the same time complexity. So if you say that, okay, if you are here and you want to delete this element, how much time this will take? Can you tell me? If you are here and you want to delete 2, how much time this will take? Can you please reply? How much time this will take? If you are here right now and your pointer is here, you want to delete the previous element, how much time this will take? Yes, Mandeep says constant. That will take constant time, because we can move, we have the address of previous node, but this might not be possible in the case of singly linked list. In singly linked list, we need to come from the head only, so that will take order of n time. In singly linked list, to delete the previous node, order of n time. In doubly linked list, delete the previous node, constant time. So this is list is the implementation of the singly linked list. List is an implementation of doubly linked list. How we declare the list? Very simple again. This is the keyword. List is a keyword. This is a data type. Is the name of the list. Here we mention L1 as the name of the list. Another way, keyword, data type, name of the list. L2, we are storing some data. We are initializing the list with some data over here. This will take order of n time. This will take order of n time to, if we have n number of elements. If we have n number of elements, that will take order of n time to create the list. So there is a one question from Divya. Divya is asking, is this doubly linked list or circular linked list? This is showing again, this link should not be here. You notice, I think, this link. Yes, I think they are just, I take it from the online source. So yes, these two diagrams were not right actually. So this link should not be here. I think that's why, Divya, you are asking. No, this link will not be there. This is a doubly linked list. It's not a circular linked list. It's a doubly linked list. Okay. Yeah, you notice right thing. So please remove this link from here. So this diagram is not, now this is fine. Okay, now this is fine. Great, you notice this thing. Fine. Okay, so this is how we declare the list, or you can say, okay, doubly linked list by using C++ STL. Fine. Okay, now let's see various methods used in the list. So front is used for accessing the first element. Back is used to access the last element. Okay, back is used to access the last element. We can access last element now. We can move forward and backward. We can push at the front. We can push at the back. We can pop from the front. We can pop from the back. We can assign the values also to the list. We can assign the value to the list. Okay, so just like a forward list. We can insert at a particular location, but this time only insert function will be used, okay, not insert after, okay, like that. Size will tell us the size of the list, okay. Size function is not with the forward list, size function is with the doubly list, this list only, not forward list. There are some other functions also like erase, to erase from a particular location, to remove a particular element, to clear your list, to check the list is empty or not, to reverse the list, to sort the list. So these many of the functions are just same as the list function only. Okay, so let's apply these function now. Let's apply these functions. Let's go through them in fast manner so that we can see, okay, how they are working. So let me go to the C++ online compiler. Let me make it empty. Now let's create the list. So very easy. Just write the list keyword. In the curly braces, write the data type and write the name of the list. So let's suppose name of the list is L1. That's it. We created our doubly linked list. We do not need to write so many stuff. Our doubly linked list is ready. Fine. Now assign is, see, assign is just working like in the singly linked list. So simply L1 dot assign, and in the curly braces whatever the element you want to insert. So inserted 3 elements inside this doubly linked list. So this list is a doubly linked list. Okay. Now I'm creating another list on which we will perform most of the operations actually. So second list I'm creating by initialization at the same time. We are initializing 50, 10, so on in the L2. So maybe okay, you can write equal to also. If you want to write equal to, that will also work fine. If you will not write, that will also work fine. So we are initializing L2 with so many elements. This is one way to assign the value directly, or with the assign also we can assign the value. Let me create one more list. List 3, and let me show you. You know already, okay. We can use the if we want to assign the repeated elements. So yes, you can use the assign function. Now 2 is repeated 5 times. 2, 2, 2, 2, 2 is stored into the L3 list. Okay. So just I show you this assign function, I show you, and I show you, okay, how you can initialize the list, and that's it. This is what I show you till now. We can access the front and last element. So for that we have a function front and back. So we have two functions, one is front, one is back. So L1 front function is returning the front value of L2, and back function will be returning the last value, that is 60. Front value is 50, L2. So this, what will be the output? 50 and 60. Yes, that will be 50. That should be 50 and 60. Yes, that is 50 and 60. That is that visible? No. So let me hide this comment and make it up little bit. Yes, the this is 50 and 60 is the output. 50 is the front of L2 and 60 is the back element. So if we want to access the front element and back element, we can use front and back functions. Just keep noting, okay, don't need to worry, means just let's go through them one time, that's it, more than enough. After that, whenever you will be using it, then that will be then only you will be remembering them for a long time. Right now just let's execute them. Now we pop the element, pop front, pop back. So 50 and 60 will be popped. This is from L2 list. 50 and 60 will be popped. Front element is 50, last element is 60. Okay, let's print it. Let's now print our list. So I'm using the loop to print the list. Okay, fine. So 50 and 60 will not be there, and all other elements will be there. So yes, 50 is deleted from the front and 60 is deleted from the last. So we can check out this thing anywhere. Any doubt you can ask me. Otherwise, let me add more thing in this. This insert operation you already know. If you want to insert at a particular location, we can use the insert function. I'm writing an insert function. You please check out and tell me what should be the output. This one, please tell me what will happen after performing these three statements. After executing these three statements, what will happen? Please reply in the chat box. Please reply. Right now your list is with you. That is also visible. Here is your list. 10, 90, 40, 70 and so on. You know that, okay, this begin will give the address of the starting element. So that is stored in this iterator it. And you know about the advance function, that is advancing the iterator by 2, that is 0 plus 2, 2. And insert will insert 5. So what will be the output? So that is very means hectic to write all that stuff. So we are inserting 5, 50, I think you have inserted. Fine, okay. So let me execute it. So I have not printed this list. So let me copy this loop so that we can print the elements. So we are printing these, our list again. So okay, we are here, we are inserting at the second position. Okay, there is one difference here, is that from the forward list, in the forward list you were inserting after. There was a word after also, but here you are inserting at this particular location. You are inserting at this particular location, second position. So at the second position you inserted 5, and we are inserting 5. Okay, so at the second position we inserted 5. One difference from the forward list, in forward list we were inserting after. If you notice, there was the word was also there after, erase after, insert after, like that. But here after word is not there, so we are inserting at the same position. Okay, no need to worry about that much. Just keep noting that, okay, this is inserting at the same position. That's it, not a big deal. This is how they have implemented. We just need to use these things later on. Our life will be more complicated when we will use them. Okay, so right now, okay, so what this will do, okay, already mentioned in the comment. Now insert 2 occurrences of 7 at it position. So at this position 2 7s will be inserted. 2 7s will be inserted at this position. It position is not changed. Okay, that is 2 only. It is 2 only. So so this will insert 7. Okay, this will insert the 2 7 actually. So I think it position will change over here. So need to verify. It position will change over here. After inserting it, it will go. Let me take, okay, this thing. Let me take this thing. Okay, it position I think will change with this function. Then if we will insert the element, then 2 7 will be inserted. 2 times the 7 will be inserted. Let's run it and check out. So let me print the elements. I have not printed the elements. Let me take the prints, this loop, and let me print them. So let me run it. This should be 577. Yeah, this is 577. Yes. So this is actually printing the IT position is changing actually with the here this is changing the after inserting 5. So now I the this IT position will be after 5 actually. So this is after 5 we are inserting 5 this 7 7. Okay, so yes, this is changing the position. Yes, that is, I had that same doubt, sir. Insert versus insert plus 1. So this is changing the position. Okay. So okay. So the idea here is that we are inserting here the main idea what you need to note is you are providing the position at which you need to insert two elements which are of 7 type. Okay. So insert two occurrence of 7 at IT position. That's it. This is the thing you need to note. Okay, this is the thing. Okay, fine. So this is the insert operation. Size operation is not in the forward list, that is available with this doubly linked list. Okay, size function is not available there, but is available here. So okay, let's run it and let's see what is the size. And the size is 11. Number of elements are 11 over here. And the remove function is just same as forward list. So you need to pass a particular element, and that will, okay, again this one you will tell me, because last time our opinion were different in remove function. Now I hope this is visible. Last status is visible of the list. This is the last status of our list. After that you are deleting, you are removing the 60. Can you tell me what should be the output? Can you tell me what should be the output? So this is working the same way what we discussed last time. Remove function is working same way. Size function was not there in the forward list. What should be the output? Keep replying, please. Just we anybody? Okay. Divya says there's 1090. So we remove 60. Okay, na? We remove, yes, we remove both the 60. Yes. Let me run it and check out. We should remove all the occurrences of that element. So I have not printed. So let me copy paste this loop to check out that. Okay, this will print without 60. So yes, 60 is not here. We can see that is visible to you people. So 60 is not here. Yes, we remove all the occurrences of 60. Fine, okay. So let's see, okay, what other function we have with us. Again, we have like erase function. So I'm taking the erase. I'm taking the erase function. Let's execute it also. Let's finish them. Here is the, we are deleting list of elements. Okay, now this time we are just deleting list of elements. You can delete a particular element also. You can pass that location and you can delete that also. But okay, here we are deleting list of elements. We created a separate iterator here, which is starting from the beginning, and you updated this to second position. So ITR1 is pointing to the second position, mean at the 5, and ITR2 is pointing to 2 plus 3. That is pointing to the fifth location. 2 plus 3, that is the fifth location. So 2, 3, 4, 5. That is pointing to the 40. So can you tell me what should be the outputs? So this is inclusive, this is exclusive. Okay. So this should delete 577. Okay. This should delete 577. So let me run it and check out. Okay, again let's take a loop to print the elements. So let's print all these elements. Yes, so we deleted 5 to 7. I hope that is visible to you. Yes, Divya, you are right. So you need to take the idea simply is that we are starting from this location and we are not deleting this location. This is inclusive, this is exclusive. That's it. Okay, fine. So let's finish other part also. Now sort and reverse function also we can apply. So let's execute those also. Same function, just like forward list only. All the functions are same only, except the we were doing the insert. So let me write the sort function. So we are sorting the L2 in increasing order, then we reverse it, that will be in decreasing order. So let's execute it and let me take this loop back to print the element so that we can see what is the status of our list. Yes, see this is sorted now. I hope that is visible. Let me make it little up. Yes, let me make it more up. Fine, okay. So here we can see that, okay, this is first sorted like 10, 20, 30, 40, 50, 40, 70, 90. Then reverse have reverse it. That's it. Fine. Okay, that's it. We gone through all the important function of the list. These are the important functions of the list. That's it. Just we have one time executed, fine. This is more than enough. What you can do maximum is you can note them down somewhere if you really want to note it, so that you can remember it. Otherwise definitely you will forget it. Means nobody can remember. We are human being, we cannot remember means all the functions. Whatever we need, we are using again and again. Their functionality we can remember only. Okay, so but okay, these are the function you will be using maximum. These are the function you will be using, uh, except the some exceptions only. Okay, fine. So let me go back to my PPT. My motive is just to make you familiarize you people with this function one time. Okay, so now let's move to the STL algorithms. There are many algorithms you already know now. At least Divya, Mandeep, you people already know. The other people, okay, for other people, they can check out the previous lectures, like count function we have used already, find function we have used already, lower bound, upper bound we have used already. So these functions and many other functions also we have used already. So these are the algorithms only. These are the algorithms, STL algorithms only, to find the element, to find particular element, to find the lower bound, to find the upper bound. So you people can check out that thing. Okay, Divya. Okay, so what I'm telling you is that I will be covering some function here which we have not covered earlier. Okay, so I will be covering only the new functions over here. I will be not adding the old function. For old function, you can check out the previous videos. And is just a reference. And is a reference. So whenever you are using the and, then you are not creating a new instance. Okay, so let me highlight your comment. So Divya, if you are writing and, then you are just let's suppose you have two names. Okay, you have two names. So let's suppose your name is Divya and your another name maybe, I don't know, maybe Krishna. Okay, so if I will call Krishna, then again you will say hello. When I will say Divya, you will say hello. It's and operator. Okay, same, just with the different name, same address location is pointed. Okay, let me take the pen. This is your data. Let me create the list itself. like 10 is to 20 is there, 30 is there. This is created in the form of list, but this is your list. If you are writing and, if you are writing and, let's suppose a, and you are accessing the element in this, so you are saying like this: a is pointing, a is pointing, a is pointing here, a is pointing at this address and accessing the element. You are accessing the element. Now you are given the name, you are assigned the name to this location, you assign the name to this location a, you assign the name to this location a, you are assigning the name to this location a, you are assigning the name to this location a. This is when you are assigning and. When you are not writing and, you are writing like directly, you are writing auto a, you are taking the element from the list. Okay, in that case this is a variable. Now in this variable you are taking the element separate. This is a variable a. You take this element, copy it here, copy the element here, take the element from this location and copy it here, then you actually processing it, then you delete, you copy the next element over here, take the element from here, copy it here, take the next element, copy it here, and then you are using that element inside the loop. Okay, so this is the two things how working. So what is the difference? The difference is that you can say that, see, you can see here in this case you are copy the element from here to this location. This is a different location which is having a name a, due to in this case, but in this case you are saying that you are assigning a name to same location, this location a. So this is more expensive actually. This is more expensive because you need to copy the data from here to here. You need to copy the data from here to here, again here to here, here to here. In this case you are not copying, you are just giving reference. You are giving reference. You are saying that okay, let me give this location itself a name. Now this location a name. Now this location a name. You are not copying the data. You are giving the name of that location itself that. Okay. Yes, using and is more efficient. Yes, two pointer. Actually, in the case of list, you don't have two pointer. You list have only one head only. But yes, the address of this location will be pointed by this address, this name also. Okay, with this name, just assigning a different name rather than calling that person over to some other place. So you are just assigning the name itself to that. So earlier the name of 10 was A, then you remove it, then you say that no, 20 you are A, then you said no, 30 you are A. So at the same location. So yes, this is faster. This, if you are writing and, that is faster. That is good practice if you are using. Okay, but that was not impacting that much. So you can use, means while executing the code, you can say that that is good practice. Okay, otherwise your program will not go in the TLE and all that. When you will solve the problem on lit code and code forces, you will not face that type of problem. But yes, you for if you want to compare, then you can say fine. Okay, so let's go through the different STL algorithms. Although some of them you have already gone here also, but I'm little bit extending them. Okay, so let me go to the compiler, and here itself let's execute the various algorithms. Let's make the space. So this is our empty editor now. So I will keep bringing the different algorithms, and thanks Piyush for your feedback. Nice to see you people here. If you want to join this course, you can go to the description and you can register for this course. This course is free of cost. Fine. Okay, now I'm taking an array. Okay, I'm taking an array. So let's perform different algorithms. I'm taking an array, so we to take an array of different elements. Fine, I'm taking a size of this array. Let me take the size of this array. So my motive is right now to just go through various functions, various STL algorithms. So here we find out the size of the array. This is giving me the size of complete array, and then I'm dividing it. Size means this is giving in bytes. In bytes that is giving me, okay. And I'm dividing with one integer byte. So this will tell me how many elements are there. Okay, let's suppose 2 elements are there, then this will give me 8. This will give me 8, and one element size is 4 byte. So yes, 8 divided by 4 is 2. So if we have 2 elements, this will give me the size of 2. Fine, okay, just I find out the size of my array. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements are there. We can sort this array using the sort function. So how to use that? So let me write over here sort function. Just this is an inbuilt sort function is available with us. So we can use that. Simply pass the starting address of the array and ending address, that will be a plus n. So starting and ending, this will just sort our array. That's it. This is the inbuilt sort algorithm already available with us. And this is actually built with the help of 3 sorting algorithm. One is quick sort, one is insertion sort, and one is heap sort. So by these 3 algorithms behind the scene is actually sorting these elements. Okay, and this is taking n log n time. If you want to sort, okay, let me print the elements so that we can see that. Let me print these array elements. So just going through a loop and printing all the elements inside the array, going through the loop and printing all the elements inside our array. So let's run it. That should be sorted. So yes, that is 1, 1, 2, 3, 4, 5, 6, 6, 7, 8. So we sorted them. We can sort it in decreasing order also. Just what we need to do, we need to add our functor, that is greater functor we need to add. So let me write that also. So you know that this greater can be used to print the element in decreasing order. Okay, so this will sort the array in decreasing order. If you want to sort in decreasing order, you can use this statement. If you want to store in increasing order, you can use this. So now this is in decreasing order, 8, 7, 6, 6. So let me remove the comment. So 8, 7, 6, 6, 5, 4, 3, 2, 1, 1. Yes. So we are just printing in the decreasing order. There is one stable sort. Do you know what is stable sort? Anybody, please let me know. Stable sort. Stable sort. Do you people know what is stable sort? 2 braces. We are talking about this. 2 braces. This is for this, and this braces is starting from here. I think you were talking about this only. Yes, Divya, you are right. Yes, Divya, you are right. Divya already gave the answer, Mandeep. Stable sort preserve the order. Means here you can notice that I have input this 6 first, and I input this 6 second place. So in the output, if this 6 is coming first, when you sort the elements and this 6 is coming first in the output also, then this is a stable sort. Okay, let me give another example. Let's suppose we have these elements with us, and I ask you, will you please sort these elements? Then what you will say? You will say, sir, are you okay? The elements are already sorted. But still I'm asking you, can you please sort it? Then Divya write this algorithm. Divya say, okay, I write an algorithm A1. So although the value are same for these numbers, but these numbers are different numbers, the value are same. So to differentiate them, I am writing subscript A, B, C, D. Okay, just to differentiate that. Okay, the value is same, but numbers are different. So Divya sort them like this: A, B, C, and D. Okay, and I write another algorithm. I sort it like this: 10B, 10A, 10D, 10C. So then we check, okay, which one is sorted? Both are sorted. Both are sorted. This is also 10, 10, 10. This is also 10, 10, 10. Both are sorted, but this algorithm is stable sort. This algorithm is using the stable sort. What do you mean by stable sort? The sequence in which you get the input, you are getting the same sequence as the output. Okay, but here I am giving different sequence. Even though I get 10B later than the 10A, but I am printing 10B first then 10A. And here also I am doing this. This coming later on in the input, but I am giving this at input output as a first. Okay, might be you can think this thing like that. Okay, you are sending the data to the satellite. Okay, and you are sending the packets or data to the satellite. I'm sending the packets to the satellite, and the satellite is streaming the data to you people at your home, sending the packets to you at your home. Now I want that whatever I'm teaching, I'm making the same dialogue, repeating again and again. I'm repeating, okay, but I want that my first dialogue must go first to you, and second dialogue must go later on. Although both dialogue are same only, but still I want that both should go in the sequence. Okay, so for if I want in sequence, then at your end you need to use the stable sort. At your end you need to use the stable sort. You want the packets in the same sequence in which they are sent. Okay, yeah, in insertion, merge and bubble are the stable sort. Fine. Okay, so we know now about the stable sort also. We can sort the vector also. If somebody give us vector, so let me take the vector. Let me erase this screen first. So we just sorted a normal array. We take the simple array and sort with the help of sort function. Fine. Now let's perform the sorting. Now let's perform the sorting on the vector. I'm creating a vector. We know how to create the vector. This is the keyword, this is the data type int, this is the name of the vector, and in the starting we have elements. These are the elements in our vector. Fine. We created a vector. Vector is a dynamic array. We know this thing. And if you don't know, you can check out the second lecture. In that we cover the vector in very detail. So we can use the sort function to sort the vector. We need to pass the starting address and end. End means end is pointing to the past the last element. Okay, so this always remain exclusive. Okay, this will remain inclusive. So this will sort the elements of the vector. That's it. And there is a reverse function also that will reverse the elements of the vector. Just I'm going through different functions. Reverse function will reverse the elements of the vector. Reverse we have already used. So this will reverse the elements. So this will store in increasing order, sort in increasing order. This will produce a decreasing order. Okay, let's see the output. So let me take a loop from here and let me print this sorted vector. So this should be now in decreasing order because we have reverse. We sorted it, but we reverse it. So because we reverse it, so this should be now decreasing. So yes, I think that is visible to you people. So that is 9866543211. Yes, we sorted it and we reverse it. Fine. Okay. Any doubt you can ask me. Otherwise, reverse function can also be used to reverse the element at a specific locations. You can give a range. Start from the third, go till the eighth. Sort these elements only. Do not reverse all the elements. Reverse means first will become the last, second will become the second last, and they will be swapped with each other. Okay, so okay, I'm writing here one command, one function. Can you please tell me what will be the output? So for this I will wait. For this I will wait. Can you tell me if we will print the data of this vector, what will be the output for this code? What will be the output? Beginning, you know that this is the vector you have. Okay, this is the vector you have. What you are doing? Reversing the elements. Okay, you are reversing the elements. So this will actually, let me tell you one thing. This will update your vector. Okay, this will update your vector. Your final vector will be like this: 9866543211. This is the final vector, and after that you are reversing it like this. Means you are going to the fourth location, 0 1 2 3 4, coming at the fifth, and eighth location is 4 5 6 7 8. This is the eighth location. So what you are doing? You are reversing these elements. You are reversing these elements. Means this will be 2 5 will come here, 3 4 will come here. These elements will be reversed only. Okay, so what I want to tell you is that a fixed range of elements you can reverse. That's it. Okay, a fixed range of elements you can reverse. So let me run it and let's check out. Let me run it and execute. So you can see here these four elements are reversed only. 5 4 3 2. These are the elements only reversed. So in a range, fixed range, you can reverse the element. Okay. Yes, Divya, you are right. So okay, there are some more function. I'm writing all together, all these function. You please tell me the output. I'm writing all of them all together. Okay. So okay, let me write one by one. Otherwise, this will not be a good idea to write all them together. We have time with us, so we can write here. You just listen, people. Okay, you just listen. What this is finding the maximum element in our vector in this range. Starting from this and going to this, we are finding maximum element. Which is the maximum element here? 9. So this should print 9. Let's execute it. So this is printing 9. Yes, this is printing 9. Likewise, there is a min element function also. Just need to go through these functions right now. Okay, whenever you will be needing them, you will be having the stuff in mind. Your mind will note that okay, there was some function over there, I can use that. 9 is printed over here. Which one you are talking about, Divya? Why 9 is not printed in first output? 9 is printed. Which one you are talking about? Here max is 9, and here this will print the minimum element. Minimum is 1. So let me execute this one also. Okay, this one you are talking about. This is a different array. This is vector. Okay, this is the vector, and here this is I think this belongs to up this array. That was the output of this array. Divya, this first output belongs to this array. Here we don't have 9. Here we have up to 8. This output belongs to this, and fine. This output belongs to this. After that, this output starting from here, our vector is starting. Vector have the 9. Yes, fine. Okay. Minimum element is returning the min, that is 1, Next function is like if you want to sum all the elements, sum function is there. Accumulate function is there. If you want to sum all the elements, so this accumulate function will sum all the elements in this vector. Let me run it. 45 will be the sum. You can add it, and we can count. Count you already know. So count function will count how many elements are there. So this will count how many elements are there. Count, you already know this. So what this is counting? Okay, this is telling how many 6's are here. How many 6 are here? How many 6 are here in our input array? See, 2 6 are here. In this vector, we have 2 6's. Yes, this is counting how many 6 are here. That's it actually. That's it. One more function you can see, find function. You already know otherwise, find function. But okay, this time we are applying it on the right now on the vector. So this is finding 5 from this range. In this range in the vector, we are finding the 5. If we don't find, then we will say element. If we don't find, we will say element not found. If find, we will say element found. So 5 we have. So we will say element found. We will print element found. Yes, element found. Fine. Why 0 in accumulate, sir? 0. 0 means telling us the from where, from which index you want to start. From which index you want to start. Okay. From sorry, not from which index from want to start. You want to start from this to this. But initial sum value is what? Initial sum value is what? 0 is the initial value. Then you are summing further. Okay, let's verify this thing. Let me write. Right now we are getting 45. So if I'm adding 10 over here, that should be 55. Okay, that should be 55. So let me execute this. So that is yes, that is the initial sum. That is initial sum. 0 is the initial sum. So we are getting 55. Okay, fine. We gone through the functions. Okay, we gone through the functions, and just go through them. Don't need to worry too much. Maximum you can do is you can note them. Otherwise, you can find the notes. If you have registered the course, then you will find out these notes also. You will find out all these functions in the PPT. Okay, Mandeep. So this is about the STL algorithms. One more thing let's cover. We have time with us. Another data structure we have. Although we do not use it that much. And the reason is we have priority queue. This data structure, make heap, is used for creating the heap, max heap or min heap. Okay, max heap or min heap. So max heap or min heap. But you know that we have already covered priority queues. We have already covered the priority queue. So this is also doing the same job. The only difference is this, you can notice, between make heap and priority queue. Priority queue is actually providing some fixed amount of functions. Okay, like you cannot access all the elements randomly, but here you can access all the elements of the heap. Okay, so if you remember, heap is of two types. One is min heap, one is max heap. In max heap, parent is greater than equal to child. Max heap follow this principle, min heap follow this principle. Parent is smaller than equal to child at every node. Okay, so you can check out this thing. Okay, Do you know the min heap and max heap? If you know, then only I will proceed. Otherwise, otherwise that will be confusing for you. And right now, explaining the min heap and max heap will be requiring time. So, if you do you know about min heap and max heap? So, if you know, then I can we can see the different functions of this also. If you don't know, then you need to practice it yourself. Please let me know, because if you don't know the min heap and max heap, first you need to know min heap and max heap. Then only you will be able to recognize, okay, what actually is happening behind the scene when you will perform one operation, another operation. Heapify you don't know. So okay, now don't need to worry. So what you need to study the heap first, then you can go for this. Okay. Otherwise, we do not need to use it. We have priority queue. This is your homework. This is your homework. Okay. To check out the make heap. Just like a priority queue. Create the min heap and max heap. Okay. Do you want me to continue this make heap? If you want, then I can. Okay, let me continue. We have time with us. So what we can do is uh, just note one thing, okay, to continue. Okay, let me erase. Let me give you a little idea about the min heap and max heap first. See, this is the min heap. This is the min heap. 10, 20, 30, 40, 50. Like this is the min heap. Means parent is smaller than the children. Parent is smaller than the children everywhere. And if I write the max heap, this is the max heap. You can notice here, parent is greater than the children. Parent is greater than children. Everywhere this will happen. Parent is greater than children. Okay, parent will be greater than children. And you can store it into the array form also. Like 10, 20, 30, 40, 50. Means first this element, then these two elements, then these two elements. Although this is showing in sorted order, but this may not be in sorted order. Okay, this is not compulsory to be in sorted order. And this array will be stored like this also, like 100, then these two, 90, 80, then these three, 60, 70, 80. So you can see here 60, 70 and 60. So you can see here this is not sorted, 60, 70, 60. So this need not be sorted. Heap need not be sorted. This is min heap, this is max heap. What is the benefit of this data structure is, you can find out the minimum element at the top in min heap. In constant time you can find out that. In the max heap you can find out the maximum element that will always be at the root, confirm. So that you can find out in constant time. Somebody asks you, out of all the elements, can you give me the maximum element? You will say yes, I can give you in constant time. That will be at the root. Okay. And if somebody asks you, what is the minimum element? I will give you 1000 element that is stored in the form of min heap. Can you give me the minimum element? Then what you will say? You will start laughing. You will say, yes, I will give you. I can solve this problem in constant time. The minimum element will be at the root only. Then he will ask you another question. Can you give me the maximum element? Can you give me the maximum element in min heap? And he will start laughing that, okay, this will take order of n time to find the maximum element in min heap, to find the maximum element in min heap, to find the minimum element in max heap, that will take order of n time. Okay. After pop top, yes, if you want to delete the element, then we will delete this element. Okay. And then we will replace this element over here. And then we will perform heapify. Same way here. Okay. So this is the min heap and max heap. Okay. It's better that this should be your homework, because without little basics, if you will move on, then you will not feel nice. It's better build our base first, then we move on. Okay, otherwise that will be it's better we build the base. Base is very much required, otherwise that will lose our confidence. We feel that we are not capable enough, but it's not because of we are not capable enough, it's because we have not built up work on the base, that's it. So it's better you work it at home. So this is your assignment to work on the make heap data structure. Last data structure we completed, so we reached to the end. That's great. Definitely you people started with me from the very starting. You are taking all the lectures. If you will finish the last series, mastering DSA also with me, I can ensure you that, I can promise you that this way, the way you are consistent right now, you people here, I can ensure you, I can promise that, okay, nobody can stop you to the product based company, because you will be, if you are working like in this way from very starting and very end, there's no reason that, if you will find out on internet, everybody will be saying that, okay, it's all about consistency, and you are showing it consistency. And yes, we completed it. Hooray, we completed our complete series. Next week I will plan another series, maybe at the mid of the next week. Okay, in maybe near about Thursday, Friday, I will plan start from the next series, and I will inform to you people. Okay, so this was a nice journey with you people. So finally we reach to the end of C++ STL. You must be feeling comfortable now. If you were not be comfortable earlier, you must be feeling comfortable now with the C++ STL. Okay, at least one thing for, okay, do you really find it useful? Any doubt you can ask me. And do you any one comment from you people about this series? Is that was really helpful, this C++ STL series? Waiting for your comments. And yes, Divya, your doubt also, any doubt please ask. So definitely we will, if we will start something and if we are doing continuously, then we will definitely reach to the end. Okay, Divya is saying that can we start practice with the C++? So maybe in the future I can plan that. In the future I can plan that, okay, but we will go in very fast manner, because maybe in 2 weeks we can complete C++ also. So maybe, okay, in the future I will think about that. Are you asking the question means should you practice C++, or are you asking to me, Divya, to skip the Java? Okay, you please suggest me also. You people please suggest me also what should be the next series we have to come up with. Like your suggestions are also matter. So you are suggesting me, okay, skip the Java and come up with the C++. Okay, I will think about that, and I will convey the same to you. I will convey that thing to you. And I'm thinking to one more series, like mastering Python for MAANG. This is another series I'm thinking about. And mastering Java collections for MAANG. This is another series I'm thinking about. So okay, we can connect on LinkedIn also. If you want to connect with me, we can connect on LinkedIn, and we can you can give me suggestions over there also. Directly you people can DM me. You can search Puneet Kansal iNeuron, and you will find me on LinkedIn, and you can give your suggestions. Okay, so we can do like this, like that. And if I will be getting some comments, from many people, if I will be getting that, then 101% I will plan that series also. Okay, fine. So okay, fine. That's it for today. I will let you know about the future series. Okay. Yes, you can skip the if you want. If you don't want to pursue with the Java, that is your choice. You can go with the C++. That is enough. And Python needs if you Python is required for if you want to go in data science, then Python is needed. Otherwise, if you want to go to competitive programming, like only for DSA, C++ is more than enough. Even for DSA, Python is also more than enough. But C++ actually is preferred because if you are working on like these platform code forces and lead code, then C++, you will find out the big community over there of C++. So you will find out the solutions of the problems very easily, and you can communicate with the people very easily because there is a big community over there. Yes, on Saturday there is an offline workshop over here. Okay, this is an announcement for all of you. We are covering an offline workshop over here, and we will be connecting. We will taking we will communicate one by one. We will check out your profile. Okay, up to what level you have reached, how much you need to improve. Okay, and what can be the best roadmap for you particularly. So for every person in this workshop, we will guide him or her what should be the right roadmap for his future. So how much skill he or she has got till now, and what can be the future plans, and specifically that will be more based upon DSA. But yes, if that is more indented toward anything else, that will also be guided based upon what they have gained. Yes, there is a workshop. Yes, Divya, on Saturday. So that is about deciding, okay, what can be the future roadmap for your career particularly. For everyone, there will be a different roadmap based upon his or her skill. Okay, then thank you. Thank you everyone. Bye bye. Take care. So you can join on Saturday offline over here with us. Bye bye. Take care. Good night.